Lesson 7.3, we have transformation of trig functions. This time we're going to talk about the amplitude. Just want you to think about the amplitude being just the height of the graph. It's a vertical stretch for us, and so we'll talk about doing that. So the first thing is kind of do a little bit of definition of it. So, so the amplitude is half the distance from max to min. And I think the other way that I also like to say, or the distance from the midline, which we will talk about in 7.4, from the max and min. So this first part, half the distance up here, I'm talking about half the distance. I just want you to think it's like, and it's like from the graph in half, like what it looks like. It's always going to be the same. Just remember, distance is positive. So we want to think about that distance is positive. Okay, so what we're going to do, so let's go to our standard form. I believe we typed this earlier, but let's make sure. So again, all transformations are pretty much the same. For trig, we call them different things, again, just based on when you're using them for job situations, like amplitude would be our A. We're not going to say it's a vertical stretch. It's just how high it goes and so forth. We think of a heartbeat on a monitor and so forth. So they don't really need to know the vertical stretch of it. They want to talk about the amplitude. So let's write our equation. So y equals A, which we're going to talk about today. Okay. Sine. Let me make sure this looks like an A here. And then the other ones that we're doing, we'll get to them in a little bit. B, and then X minus C, close this, plus D. So when you are using, doing your trig functions and using different ones, think of like when you're graphing quadratics or something. So for example, if I put over here y equals ax minus h squared plus k, we know what a does. So we're actually talking about the same thing. This a and this a are pretty much the same thing. It's just called amplitude on trig functions. Just going to determine how high you go, and so forth. So what we're going to do next is we're going to put these three in a graph, using different symbols and so forth. I'm going to, if you don't know how, I'm going to show you how to do that, and then we'll graph them on the graph paper, okay? So get your graphing calculator out. All right, so we're going to do sine x here. With that, enter. Then the next one we'll do, I believe it was 2 sine x, okay? So that's going to be in the front, so 2. Then type in sine, and then the x, and close that parentheses. And what we're going to do is we're going to change this type of graph, like instead of a solid line, into a dashed line. So what you do is you arrow over all the way to the color, hit enter, and then you can change the color there if you want, arrow down to get to this line. And it's showing you arrows left and right. So I'm going to go until those two are shading above and below, until I get to this line. It's like a big dotted line. Okay, then go down to OK, and then hit enter. Okay, and then the next one is going to be 3 sine, 3 sine x. Okay, and then I'm going to arrow over, and this time I'm going to do the same thing. Go to this color, hit enter, determine what color you want. I'm going to keep it black, but then this time I'm going to do a smaller looking kind of little dots. They're smaller looking than the other one. Hit go down, hit enter, hit OK. Now before we do anything, we got to do a window. Our window is telling us what to our scales should be. Oops. Sorry, I'll do this again for some reason. All right. So now I'm going to go to my window. I'm going from negative to pi. Don't forget the pi key is right there below caret. That's minimum. The max is going to be 2 pi. It always goes into a decimal. And then our scale is going to be pi divided by 2. So just like we do. Remember, those are the quadrantal angles. So you're going to hit second and the pi key, divide by 2. And then according to this, they went -3 to 3. I think I did -4 and 4 in class. So I'm just going to do, the only reason I like -4 is I can see the top of my graph. But if you do 3 and 3, that's fine. And the scale stays 1. So now you can hit graph. Okay. So I'm going to see if I can zoom this in a little bit more. I don't know if I can. But if you can see, there are 3 different lines going there, okay? So for our this is dash, this is the 3x, okay? You can see the amplitude going up, and then the red one was going up by 2, and the amplitude was 2, and here is just the blue one is our parent function, okay? This is, if you can see, the graph is just stretching higher. So A just makes it stretch higher and lower. But the same distance between here. This is our midline for us right now, is this the x-axis, but that's our midline where y equals 0, okay? So what you do is to graph these 3. Okay, so I'm going to graph these 3, excuse me. I'm just going to use different colors. So the first one I think it's kind of a pinkish color. But what I'm going to do is as I'm graphing, I'm going to say what I normally say when I graph it, because it's the same process every time you graph sine, cosine graph, and we're doing the same sine, cosine graph throughout these transformations. So when I know a parent function, it starts at the sine of 0 is 0, so it starts here at the midline, because this is your midline here. It goes up to the max, which we know is 1. So at pi over 2, it's 1. Comes down to the midline, 0. The minimum here is -1, so -1 there. And then back to the midline. So again, just watching how I say it, so it helps me. And then I go back this way. I can go back the opposite way. I'll just do that in a second. Let me graph this. Graphing nice and neat makes a difference. If your graph should represent what you're graphing, not just, yes, it's this kind of up and down motion, but it should be pretty accurate. You know the values at certain parts. You know what it looks like if you know the parent function. And then reflect over here as we keep going. So I'm showing 2 periods, okay? Now for the other ones, I'm probably just going to do just the first period between 0 and 2 pi. So this 2x, I'll just do in this color, blue. And this was the bigger dots when we did this, okay? So you start at 0, still starts the midline. So it's going to go up to 2, which is the max, come back down to the midline at pi, go to the minimum, then back to the midline. Sometimes I have to catch what I'm saying. I feel like I repeat too many times. Okay. And the next one we're going to do, I want to do in this color. And these are little tinier dots. You see those? But again, I'm going to repeat the same process. It starts the midline at 0. The max this time is 3. So it's going to go up to 3. Come back to the midline. Come down to the minimum, which is a -3. And then back to the midline. Oh, the other one's supposed to be dashed, wasn't it? Oops, they did a very good job there. Let me go eraser and kind of erase that one. But the thing what you look at is when you're doing this is making sure that you are paying attention to where you're going with the graph. Notice that the shape is still the same. It should look the same. I'm trying to make this dashed. Not doing very good. It should look the same. Noticing again that where the amplitude is. So the amplitude for us, you think about it, from here to here for our sine graph, that's a 1. And that's because there's a 1 in front of here. So your A for here is 1. But if you notice on the blue, and I'll go over here on this side, from the midline down to this one, that's a distance of 2. So again, here A is 2. And then the same thing with the 3, it just comes, I'm just going to use this side, it goes up here all the way up to 3. And the distance is positive. So A just stretches that out. All right, let's fill in our little box here. In standard form, y equals a, a sine x, a right here, represents the amplitude. Again, that's the name of it. We're just used to representing a vertical stretch. I'm going to add a little bit to this because I kind of like the definition that I found in the book. So it describes the height of the graph above and below the midline. Okay, and the midline is a horizontal line, so that's a y equals line. So we'll talk more about that next. Okay, so I graphed in my calculator, put these two in. You already had a 2 sine x, so I just took everything in now. I'm putting negative 2 sine x, starting with number 2 here, just so we can see this. And so probably here on out, I'll probably not be doing calculators much to reduce the time of this video. But so when I graph this, if you notice the blue is the parent function, and the red is just, it flipped over. It's the reflection. So remember, the negative is just a reflection. The amplitude is still 2, okay? It's so if you see here where it goes up here, this is still 2. This is still down here to 2. Even here too, everything's still 2 the distance from this midline, but it's still just saying that what we're talking about here is just that the amplitude, just because it's a negative, does not mean it's a negative 2, because it's distance. The negative, remember, is all about the reflection. So we're going to graph these two on these 2 different number lines here, going from all the way across. Again, I'll probably start doing where I don't do as much, maybe all the way from negative 2 pi to pi. But again, you should know how to graph on both sides of that y-axis. So if I do, I know my amplitude is 2. So again, just always stating how I'm going to draw. All right, so we're going to graph this one. This is y equals 2x. So, and we're going to, here our A is right here at 2. So that's our amplitude. Okay, that's how high and how low we want to go. Again, same kind of values we use. So I'm going to start here at the midline. I'm going to go up to 2, which is my amplitude. That's my max. Start here at the midline, come down to my minimum, and back to the midline. Same thing on this side. I start at the midline. I'm going to go down to the minimum. It's kind of a reflection. It's got to be the, okay? And then it's going to be up to the midline, and then up to the max, and down to the midline, okay? So it has to be, it's, remember, periodic functions are nice. You're seeing you're completing the graph. So it should keep flowing and keep flowing. All right, so draw this. Okay, so here I've drawn the y equals 2 sine x. And then what I'm going to draw is the next one is the y equals negative 2 sine x. But again, just to remind you that this is a reflection. So that means we flipped over the x-axis because the negative's on the outside there, okay? So again, same thing's going to happen, but instead of going, I start still at the midline. And just to kind of help you, if you remember where, like you go halfway, so I'm going to put a little dot there. But then at the minimum is where I go next, okay? And then I'll put a little dot there. A halfway mark helps me to make sure my graph is a little more accurate. And then here's the midline. And then we go to the max. And then the midline again. I'm going to go the other way. And here, since I was in the minimum over here, I'm going to do the max, midline, minimum, midline. Okay, so there's the reflection of it. And again, I put the y equals the midline for each of these, okay? And so the thing to think about too is this is your amplitude. From here to here is a 2. From here to here is a 2, not a -2, a 2. That's the distance measurement. So we want to fill out this box. Let's go in standard form. Y equals a sine x. So when a is negative, so make sure you're talking about negative here, number, the graph reflects over the x-axis. Reflects over the x-axis. And we knew that from just other transformations, so it has not changed. So now we're going to use no calculator. We're just going to do this with what we know. And so there's going to be a few things I'll add to this. I think this one, I'm only going to graph the negative. I think we have the idea of the sine x. So I'm just going to graph this one here, the negative. And so for us, we're going to do on the graph an interval. This time we're doing an interval notation, so that inequality notation. And so our period for all sines and cosine, cosecant, and secant graphs is 2 pi until we talk about the period shift, okay? The amplitude for us is 3, okay? We do know, and I'll just write my little notes, reflects over the x-axis because it's negative right here. And then when we get done, we'll state the range too. Always state the range domain. Okay, so let's graph it. And cosine, excuse me, this is sine, so sine starts here at the midline. And we're going to go down to 3, which is your minimum, back to the midline, up to 3, and down here to the midline. Okay. That's not an arrow, that's just a dot there. And your midline is here. Again, I'm not going to keep going. I think you have the idea on the other side, but so I'm just going to go from 0 to 2 pi. Only so it for time's sake. Now, what is the range? The range is from the minimum, which is -3, to the max. To your 3 up here. So for this graph, I changed the y values on this. Again, I'm just going to go from 0 to 2 pi. In the notes, I believe I went all the way, but for video's sake, it'd be faster to just go this way. So what I did is I just did that because the amplitude now is 1/2. And so I can at least be a little easier to see it on this graph. You can do that. It doesn't matter if there's no numbers there. Create your own scale, but make sure it's the correct scale. Again, so same process. I'm going to do the positive. Start here at 0. I'm going to go start at midline. I'm going to go up to the half, because that's what our amplitude tells us. That's our max, midline, minimum, midline. Graph it. So I'm going to graph it. Come back and graph, show on the same axis the negative as well. Okay, so both graphs are on here. The purple is the reflection. Again, amplitude here is still A equals 1/2. The reflection, but this has a reflection. So the period for both, again, is still 2 pi. The amplitude is still the same, 1/2. The range for both is the same. -1/2 to 1/2. Okay, so let's graph both of these. Again, I'm going to do cosine, and I'm going to do both of them so we know which one to do. So I'm going to do the parent function with this one. Amplitude for both of these is 1. We're not shifting anywhere. There's no a in front of those for this first one. And the period's still 2 pi. So for the first y equals cosine x, that's period and amplitude. Okay, so now let's just graph it. Now, the thing is that cosine starts at the maximum, goes to the midline, down to the minimum, back up to the midline, then the maximum again. I'm doing on the other side of the axis. We start here at the, I'm going to start here at the max in the middle here, and when it's 0. And then again go to the midline and go down to the minimum, up to the midline, and then to the maximum. Okay, so go ahead and draw that in. All right, here's this graph, just your parent function, so don't forget the range. Negative 1 to 1. All right, on the other graph, we have a equals 2. Okay, so let's just plot the point real quick, and then you're going to graph it. So I'm going to start at the max, come down to the midline, then to the minimum at negative 2, then back to the midline, then up to the max at 2. Going the other way, so we start the max, then go to the midline, minimum, negative 2, midline, and then max. All right, there's a graph. So the period is still 2 pi, and this time the range, though, is from negative 2 to 2. So it's the max, the minimum, to the max. All right, we'll do number 6 and come back and check. All right, so this is what your 2 graphs should look like. It's kind of hard, the scale that we have there. We could have moved it up, but see how small how that one is. But both have the midline, both are reflections. So the midline were both at 0, but then we had a reflection.